Hello and welcome to this video about the split, apply, combine technique. So split, apply, combine is a data analysis technique which is extremely common and extremely useful. And you might think, okay, a whole video about one technique, that sounds like a lot. But you can use the split, apply, combine technique for a lot. So that's why we're going to spend a whole video on it. So yeah, what is it? One example is if you want to compute the average employment rate within, so you have a data set of municipalities and multiple years, something we'll be looking at, and you want to compute the average employment rate within a municipality over time and calculate whether the employment rate in each year is above or below that average. So you want for each municipality to calculate the average, and then for each municipality year, you want to compare the observation to the average for the municipality across years. How do you do that without knowing any methods or anything? It's a bit tricky. You would come up with all sorts of loop and conditions and stuff like that. And this is where the split, apply, combine method comes in. First you split, you divide the data set into units that are more manageable and sort of has the relevant information for each operation you want to do. So in our example, that's one for each municipality with all the years. Then you apply your operations, whatever you want to do. In this case, it's compute the average employment rate for each unit. So you have a large data set, you split it into small data for each municipalities, and then you calculate the average within each municipality. And then you combine them, you merge them all back together into the original data set. Pandas is set up to do this really easily. Often it's very easy to do once you get the hang of it. And it's very common in Pandas, it's also common in other programming languages. So let's just get to it. We download our packages, nothing new here. NumPy, pandas, and some plotting. Then we read a CSV file of the employment rates for different municipalities across time. And then we clean it up a bit. We rename employment to E, just smaller. You can sort of apply operations to this data set immediately. It's just one large data set. So for example, if you write .mean, then you calculate the mean for the entire data set. So that's sort of an unconditional mean, so not conditioning on municipalities. And because this is only one number you get out, Pandas will sort of automatically broadcast it into every single cell here. So we can also just look at the mean. You see that's 74.1, so you can see that it's above this one but below this one. That's why it's negative and positive and stuff like that. You can also sort it by municipality or by year to have it like a bit more ordered. I think this is sorted by year, and then there's no sorting on the municipalities. And then we can see sort of how it looks for a single municipality. But we wanted this mean to be conditional on the municipality. And what you do that here is then you start splitting the dataset using the group by method. So what group by does is it does the splitting for you. So here we're grouping by municipality. You can also group on other variables, and you can group out a list of variables. So just writing here, for example, but then you only have one observation. So we're grouping by municipality, so we're, for example, just taking all of the OpenRO observations out into its own data set, and then we're calculating the mean for each data set. So for OpenRO, for Copenhagen, for Dragør, blah blah. And here we're just showing the first. So the OpenRO mean, the Aalborg mean, the Aarhus mean, the Albertslund means. And this is sort of the split, and this is the apply. We haven't combined yet. And here we're just saying mean. You can also like explicitly say apply, but it's the same. This is a method in pandas called apply, where you can sort of specify functions as an argument, which will then be called on the data set. And there's a lot of built-in functions, like mean, max, so the maximum, median. There's a list later, but for now it's mean. But the apply function is very general, and very sort of, you can do a lot of things with it, because it can take custom functions. So we can create our own functions and insert them into here. For this case, it will just, our input x will be a Pandas series with the employment rates for the municipality for each year. So how we would calculate the mean would just be the sum of that divided by its size, so how many observations there are, and then we get the exact same. This is slower if you have, it doesn't matter with a small data set, but in general doing these custom functions is a bit slower than having the built-in functions where you just write it, because then some very good programmer has already like optimized everything and vectorized it and stuff like that. Sometimes they even write the underlying code in the C code. And that's this warning, and so this is just I'll show you more of that later, just to show you the apply method. You can also just write other functions. That's actually pretty useful sometimes. You can just write, for example, np.mean, and then Python will call the numpy function np.mean on each data set. This is a different example of that actually, where we taking the mean difference. So how much does the employment rate change each year on average? So you can see that on average the employment rate has been going up. This only works because we've already sorted our data on municipality and year. So within each municipality, the data set is sorted. That should be sort of noted that you need to do that first. But yeah, we can call the apply method with this function that calculate the difference first, and then the mean of that difference. And you can also do it using sort of NumPy implementations. And one thing, so the x argument here will be a series. Sometimes it can also be a whole pandas dataset if it has multiple elements. So here we're creating the group by object, and then we're only extracting the e column. There will also be, because it's a fuller dataset, there will also be a year column and an MBOD mean column. But we don't want to do operations on that, so we only take the e column out. And that's what sort of gets in as the x here, that we're applying it on. What I want to say was that if you want to do Python functions, then it's sometimes better, and especially it's necessary if you want to do indexing, as if you're operating with a NumPy array, to call it on x.values, because dot values turns the series into a NumPy array, and then you can index it like this instead of having used the log or the sort of the pandas indexing. This is indexing like it's a NumPy array. I should also note that sort of using this multiple methods in one line is called method chaining. It's very popular and very common in pandas data frame thing. It's also common to do in R, and it's a good way to write nice looking code Sometimes if it gets too long, then you can sort of make multiple lines like this. Yeah, just by having a new line, but placing it sort of from the brackets, so Python will also make it know that you're writing multiple lines. And it's good for writing sort of readable code. It can sometimes be a bit daunting, like having all this. Yeah, you can do this. So I would do it like this. Yeah. It can sometimes be a bit daunting because you have all these methods. But once you get hang of how to read them, and you also, I think I use a lot like this VS Code stuff, where if you press on this, then you know that the brackets end over here, because Python tells you. And sometimes it's also memory efficient. Instead of writing multiple lines, storing the group by object, storing the apply object, and then printing out the head. Here we're just doing it in one go, and we're not really storing anything but the head output. Yes, and then we can use this to plot out what we have created. Or this is something else, but you're sort of using this group by method, and now we are calculating the standard deviation. But you calculate the mean like this, and then you're using sort of the inbuilt functionality of pandas, which are connected to Matplotlib, of how to plot. So here we create the figure object initially, and then we're calling the plot, which just does a line plot, and we're just telling it with axis to plot this on, and the style of the line plot, and setting y label and title. Yes, and this is sort of splitting, applying, and combining, but now we're gonna do it more more ordered and more structurally. So our goal is to calculate within municipality differences to mean employment rate. And now we just do it very orderly. So we start by splitting the series into municipalities, so we're saving it, so we're not doing this chained assignments. And then you can see that the group by object is it's a pandas object, which is called series group by, and you cannot really use it for anything. It's just, I mean, nothing comes out of it. There's a lot of data stored in it, but you need to do the apply part to get something useful out of it. So now we're doing the apply, which is calculating the mean on this group by object. And now we have the mean for each municipality. So we have created a split data set for each municipality. It's sort of stored in one variable, but pandas understand it as a split data set. And then we calculate the mean for each data set or for each municipality, print it out. We need to change the name of the series. That's sort of a formality because we want to combine the data set back onto the main data set, which had the municipality for each year. To do that, we need some kind of merging. We're going to do a join. Manager one left join is typically easy. You can also just do a merge, but sort of what comes out of the group by object is a series or pandas data frame that has the group by variable as its index. And when you're merging on index, then it's easy to do join. On the original dataset, we did not have municipality as the index, so we need to set the index of impl to municipality, and then we can just join with the series that had the index, and then we do a manager one left joined, because there are multiple observations in the original dataset. So for each municipality, there are multiple years observations. In the mean dataset, there is only one observation per municipality, so it's a manager one because we're joining on municipality, and then we want to keep like all the observations in our original dataset. Then we can calculate the d mean variable, which is using the mean within municipality. So that's where the name comes in. So this name is going to be the name of the new variable in our dataset. And now we can just sort of look at it where we'll extract the rows for Copenhagen. And this can be done like this. So extracting the index, saying that has to be equal to Copenhagen, and then you just do impl.log of that condition and printing all the variables. When municipality is in the index, it can also be done a little bit quicker by using the XS method and just whatever index value you want to extract. But this is sort of, I think this is the more general formulation of how to do it, and this is the quick one when you have it as the index. Yeah, so now we have the d mean. So this is the mean, which is constant across Copenhagen, and this is this is the old one that we calculated, which was using the mean for all the municipalities in all the years, and this is the d mean one within a year, or within municipality. Sorry, and we can also take something like Aarhus, which maybe it was with an O. Or maybe it was just with a large A. Yes. With this XS. You could also switch it here, and then you will need to not print it, the first one. And then we see that it's different, and this E mean is different than the Copenhagen one. Yes. And we can plot it for each municipalities. So just picking 3 random municipalities, and then we just sort of loop through and plot all 3. So extracting the municipality and saying I want to plot it on this axis, and give it this label. The label is the municipality name. And then we can see like Copenhagen had relative to its own mean, it had it relatively worse in the early years, a bit better in the later years, while Roskilde Lejre had it good, but relatively good right after the financial crisis, and relatively bad to Copenhagen in later years. So this is using the mean from this, so they are, of course, the average of this will be 0 for all of them. And this was one way of doing the split, apply, combine, where it's sort of very structured how you do it. You can do it a bit quicker and using different functions. So you can, for example, use ACK, which is very similar to apply, but allows you to do more than one statistics at a time. And you can also calculate different statistics for different variables. So in this case, we just want to calculate multiple statistics for one variable. So what you do is you still use group by, and then you use .ACK. ACK stands for aggregate, because it sort of aggregates statistics. And here we will calculate both the mean and the standard error. And then you choose the columns. You just have to rename the columns. So now that we're calculating 2 things, then this output data set would actually be a data frame instead of a series. It will still have municipality as an index, so it's still easy to use the join method, but we're gonna calculate, it's just gonna in that, so we can run it and then see just so just this mean that comes out. Maybe I'll just calculate it here. What comes out of this is sort of a data frame with mean as one variable and standard deviation as the other name, and they're both sort of implicitly coming from E, but Python doesn't tell us, the data frame doesn't tell us that, so that's why we want to rename it. You could also imagine that you had multiple variables that you want to do this on. So for example, the mean, impl mean, and sort of what, there's a small warning here because I did a bit wrong, but then you get a multi-index columns, thing out here, but you sort of calculate multiple statistics for each. Typically, you don't want to just like explode with statistics. So maybe what we actually wanted was to calculate for E, we wanted the mean, while for impl d mean, we wanted the standard deviation, and then you input a data frame implicitly. Oh yeah, okay. This is so the error I'm making here is this. Yeah, okay. So that was just because I'm extracting multiple columns, so I need to do a double list. So I'm extracting this list of columns. So here you have the mean for A and the standard deviation for impl d mean. Again, you need to change the name of the variables to whatever you want out of it. So let's just see. Then it doesn't create an error, but it will still create this multi-index columns, which we are not that happy about right now, because you need to learn how to deal with them later. Yeah, but this is the exact, so multi-index columns is the exact same as a multi-index. It's just in the columns row. They can be useful, but they're sometimes just a bit annoying to deal with. You would rather just, I mean, personally I think I would rather just have it called E mean, E standard deviation, impl mean, impl standard deviation. But you can change that using rename or reset columns. Yeah, that was a bit of a detour. That was just to show you how E mean looks and sort of what you can do, different things you can do with aggregate and having multiple columns. So we rename them, and then we do the combine. This is the exact same as before, and then we can calculate the difference because we have this mean now, and then we get this out, and the numbers are the exact same as before. So that's the one we had up here. Yeah, cool. And then there's this question about whether dangerous is a variable named diff. Questions is a bit leading, so maybe the question is more, what are these dangers? Maybe you can think about it a bit. I'll just take a sip. The danger is that that the diff is just called diff. It's not really, the name does not imply that it's a difference between these two or these two or these two. So it's sort of, it's a bit ambiguous what it is, and it's very nice in data analysis to simply be very sort of clear on what your variables are, because you're gonna forget what they are when you go back to your data analysis after a week or 2 weeks, and then you have to dig through the code. What was it that you actually created? Yeah, and sort of doing this where you have to merge stuff together and you're doing the multiple steps is brilliant in one way, but it's also a bit cumbersome. It's many lines and stuff like that. And in Pandas, there are actually tools to do it with less code, which is really nice. Yeah, you can use the transform. Basically, the most important difference between transform and apply is that it sort of preserves the original shape of the data set, so you don't need to merge anymore. You can just sort of add it directly as a variable. But another difference between transform and apply, which is also the same for ACK as for transform, is that transform only works on one variable or column at a time, while apply works for all of them. In our case, we sort of only select one variable anyway from this group by object, but you don't always do that. Sometimes you have multiple variables, as I showed you. Also with having input the mean and then apply and transform sort of operates differently. Yeah. So in apply, you're sort of applying it on its entire data frame for your subsample, while in transform and act, you're applying this function for each column. This is sort of a subtle difference because you typically only apply it on one variable at a time either way. But sometimes you want to use apply because you can sort of use multiple columns for one operations. And there's also a link to that here. And when you only choose one variable, then they behave similarly. So here the main thing about transform is that it preserves the original shape of the dataset. So even though you're grouped by on municipality, then when you're using transform, then your dataset will not go from having one observation per municipality and year to having one observation per municipality. It will sort of keep the number of observations and their order, even though it's outputting the same number multiple times. So let me just print that for you. Wait. In this case it's not. So in this case, if you're just calculating the mean, then it will be the same number multiple times. Here when you have x, then it's actually either way a new number for each year. Yeah, and you could have just choose apply because you have x out here. I'll show you later the different shapes stuff. But you can just create it as a new variable because this output has the same shape as the original, so it has the same number of observations, not the same shape. And then you can just create a new column. So that here you're just sort of doing the combine step by adding a new column to your original dataset. And you can check if you want, these numbers are the same. And then here, if you're sort of aggregating into fewer observations, so if you're, for example, just calculating the mean, then you only have 99 observations if you're using apply. But if you're using transform, then you will have 1386, which is also the number of observations in the original dataset. And this is why you can sort of also just put it into a column directly, even though you're not necessarily doing something. Even though you're not necessarily doing something that sort of, even though you're doing something that collapses the dataset a bit. Yeah. Then I have a section about optimizing performance. Generally, you should only optimize once if it's a problem. So you should create your code to do whatever you want to do. Make sure that you are calculating the correct numbers and outputting whatever you want to output. But sometimes you do that and then you run it, and then maybe you run it on a subsample of dataset, and so you know it's correct, but it's just incredibly slow. And that's when you want to optimize performance. Not before, because then it's sort of a waste of time. If you spend 2 hours sort of trying to create the most efficient code, and then things run in 2 seconds instead of half a minute, so that saves you just under half a minute, but you spend multiple hours sort of writing the actual code, then that will not save you time overall, especially because like time running code you can actually do something else. But of course, once it gets into half hours to run code, then it can be annoying, especially okay, I change a little bit and then I want to rerun it and then I have to wait and see what comes out and stuff like that. but it's just important to emphasize that it's not really that important to make your code super efficient unless you're working on very large data sets where it's actually a problem that things run a bit slowly. This is where you sort of, if you're using apply or transform or aggregate with custom functions, then pandas is basically doing a loop, and loops in Python, like custom loops in Python, are very, very inefficient generally. If you're using custom or built-in functions from pandas, then they typically do something where they vectorize it or sort of create these loops in a smart way and sort of bypass the custom loop problems where you're sort of doing one operation, or one operation, sort of can do it multiple things at once using smarter code, basically. So this is why you should generally try to use built-in functions. So this will be a problem if you're sort of doing something many times. So here we're using the time module to look at the times, and then you can see that it takes 5 seconds to do this 300 times using transform and our custom dmean function, where we're just taking x minus the mean, where we're actually using a built-in function to calculate the mean, but it's not built in to do the subtraction. And then in the other case, so we're doing the subtraction within these loops, within the group by stuff, where it's actually much faster just to do it on the data frame as a whole. So you demean by subtracting it outside of this transform loop, and you're just calculating the mean using a built-in function. There's also a difference between saying I want the mean and calculating the mean within the function. And the reason that's a difference between those is that you sort of, when you're just saying the mean here, then pandas is already optimizing before it's even going into this function. So it's when there's a big difference between having a lambda function in here and having a built-in something, because pandas knows exactly what it's trying to do, then it can do it in different ways. Sometimes there can be small differences because of this floating point arithmetics stuff, so it's not actually the exact same answer you get out, but we can see that the difference is just decimals, by using this np.isClose, so checking if they're sort of very close to each other. Yes. And also typically, if you can't do something with built-in methods, then you should try to do it with NumPy methods. So this is using the diff for series, so that it's actually a built-in method, but still a lambda function, and then calculating the mean using pandas. And that's one way to do it, and then we calculate the time for doing it 300 times. And then if you use a NumPy implementation instead, so extracting the values and then sort of extracting using this indexing stuff, which is the same as doing a differencing. So you're taking, in the first array, you're sort of skipping the very first value, and in the second array you're skipping the very last value, and then you're subtracting it, and that's at first differences. And then you're applying that function, you calculate the mean, and you can see that it's also much faster. And in this case, they actually give the exact same answer, at least on my computer. And you get the exact same result. Another thing that can be important is sort of having the correct types in here. So this is a new point in terms of optimizing. So here we have municipality as an object that should maybe be a string, but we know there are no missing values in that category, so it's not a big problem, but could be a issue. I think maybe you can also save some space. Year is an integer, that's fine. E and empty mean has to be floats. One thing you can do with municipality, instead of putting them into strings, which I think it's a bit more memory efficient, we can check that actually. So you can see sort of the memory usage of the whole data set is 86.4. It's not an exact number, but it's sort of a circle number. And then we can see we lose the plus when we're not using strings. But it's not much of a difference. One thing that will make a difference is to use a category variable instead of a string. Because we have municipalities are sort of, there's a lot of repeated values of Copenhagen. You know that there are one Copenhagen for each year, and then it's sometimes much more efficient to have categories. This is very true if you have some variable like education level where there are only like 5 possible values. Then it's much easier for pandas to say, okay, we know there are 5 values, we can just store them as the numbers, and then we have the actual values stored somewhere else. So we turn municipality as type into a category, and then we can see that we're sort of saving some memory. And you can also sometimes you can do faster operations using categories. Yes. If you need more complex Goof stuff, then you can look here. This was the most important thing. Now I just have a bunch of links you can look into for optimizing. Sort of a small discussion on when you should use apply and its downsides. You should typically try. I mean, the main conclusion here is just you should try to use these built-in methods in pandas if you want to optimize your code. And there's also some talk about NumPy vectorization. Then we have a list of all the built-in functions that you can use, or not all of them, but a lot of them, then you use in pandas to sort of optimize stuff. So all of these functions are stuff that you can write in to apply and transform and act as a string, and then Python will do it in a fast way. Yeah, and you can also, I think all of them you can also write as a method. So dataset or series dot count bracket, and then we'll count number of non-observations. And then there's a data game cheesy with some quick, very common operations that you want to do with your pandas dataset. Yes, that was all for me today. Thank you for watching.